Have you ever stopped to think about what actually happens the moment you click on a link or fire up a video? Well, today we're going to explore that very first step of the journey. We're talking about the network edge. It's the part of the internet that you can actually see and touch. And believe me, it's where every single thing you do online begins. So let's dive right in.
I mean, think about it. You're connected right now watching this. But how? What is that invisible link that's connecting your screen to, well, the entire rest of the digital world? That's the big question, and that's exactly what we're about to break down.
So, that whole journey starts at a place that engineers call the network edge. And this isn't some high-tech, faraway data center. Nope, it's right there with you. It's the phone in your hand, the laptop on your desk, your smart TV, all of it. These are the endpoints, the very edges of the internet.
Now, in the language of networking, all your devices have a specific name. They're called hosts. A host is basically any end device that's running an app to connect to the network. And it's a two-way street, you know? When you're browsing a website, your device is a client. It's requesting information. But it can also be a server, providing information, like if you're doing a peer-to-peer file transfer.
Okay, so you've got your device, your host, but how in the world does it get onto that massive internet superhighway? Well, it needs an on-ramp, right? And in the world of networks, that on-ramp has a name, the access network.
The access network is pretty much exactly what it sounds like. It's the physical connection, the actual wires or airwaves, that links your device to the very first router out there on the global internet. It's the bridge from your little corner of the world to the massive digital universe. And yeah, without it, you're totally offline.
And we use these access networks constantly, probably without even thinking about it. You've got your residential network at home, your institutional one when you're at work or school, and of course the mobile network that keeps us connected when we're out and about. Let's kick things off with the one most of us are probably using this very second.
For most of us, home is where the internet is. This is the world of residential access, and for decades, this world has been dominated by two major technologies.
That's right, cable and DSL. You've definitely heard of them. Both of them use the wires that are already in your house to get you online, but, and this is a big but, they do it in completely different ways.
And here it is, the single most important difference: shared versus dedicated. Cable internet runs over your TV lines, and it is a shared resource. It's kind of like a party line for your whole neighborhood. If everyone on your block starts streaming 4K movies at the same time, yeah, you're going to feel that slowdown. DSL, on the other hand, uses your phone lines to give you a dedicated, private connection straight to the phone company. That line is all yours. Now, this chart really drives the speed difference home. As you can see, cable offers way higher potential top speeds. I mean, look at that difference. But just remember, that big number is the speed that's shared among all your neighbors. Oh, and both of these technologies are asymmetric. That's just a fancy way of saying they're designed for much faster downloads than uploads, because, let's face it, most of us are consuming content, not sending massive files out into the world.
But come on, these days, wires almost feel a little old school, don't they? We live in a wireless world, and that world is dominated by two technologies that we use every single day, but they are fundamentally very different from each other.
Think of Wi-Fi as your own personal internet bubble. It creates what's called a wireless local area network, or a LAN. It's perfect for your house, a coffee shop, and office. It covers a pretty small area. Cellular, though, that's a whole other game. That's a wide area network. Its towers are designed to cover huge distances, we're talking kilometers, to make sure you stay connected no matter where you go. So we've got all these different ways to get online, but what is actually moving through all these connections? It's not just one continuous, unbroken stream of data. The way it works is actually a lot more clever than that.
See, instead of trying to send a huge file all at once, your device is smart. It chops it up into thousands, sometimes millions, of tiny little pieces called packets. The best analogy is a digital mailroom, taking a giant book and sending it one page at a time, each in its own tiny little envelope. The process is actually pretty simple, but it is incredibly efficient. Your device takes the file, it breaks it into all those little packets, slaps a header, which is just the address information on each one, and then it sends them out one by one into the network.
Okay, so what do these packets actually travel on? They move through what's called the physical media. We're talking about the actual, tangible infrastructure of the internet. This is real stuff: copper wires, glass fiber optic cables, and of course the invisible radio waves all around us. And this table here breaks it down really nicely. You've got your twisted pair and your coaxial cables. Those are for DSL and cable internet, and they send data as electrical signals. Then you've got fiber optics, which uses tiny pulses of light. That's why it is just so unbelievably fast. And finally, radio waves. These are the foundation for absolutely everything wireless, from your Wi-Fi router to the closest 5G cell tower.
But as this quote points out, sending signals through the air is really, really hard. Wireless signals are kind of fragile. They bounce off buildings, they get totally blocked by walls, and they have to fight for space against interference from a million other devices. Honestly, making wireless as reliable as it is today is a serious engineering marvel. So there you have it. From dedicated wires and shared cables to local Wi-Fi bubbles and massive cellular networks, we have more ways to connect than ever before. All of them firing tiny digital packets back and forth at the speed of light. Each one has its place. The really big question now is, as our world gets more and more connected, which of these paths to the internet is going to be the one that powers our future?